All right, so we're going to begin vectors, which is our new unit for projectile motion. So let's get started. We're just going to jump in and do some definitions. So the first thing I want to do is I want to give you the Cartesian definition of a vector. So the first definition we have, the Cartesian vector definition, is that a vector is an ordered pair whose geometric representation is an arrow. So this is just, there's a lot here in this definition. And yes, you are expected to speak this technical language and be comfortable with it. So a vector is an ordered pair whose geometric representation is an arrow. So what does that mean? It means this. I will write it with a V for vector with a little arrow on it. That's how you write a vector. So this denotes vector. So get used to that notation. And when you actually see it typed, it'll be typed in boldface. So let's say I'll write an ordered pair here. So like 3, 4. Okay. And then if I were to actually represent this vector on a coordinate plane, which is how we represent vectors, we go 1, 2, 3, 4, 1, 2, 3, 4. The way I would represent this is that I'd go over 1, 2, 3, and up 1, 2, 3, 4, like that. So that's how I represent a vector. Thanks, Mr. Farrell. So that's how a vector is represented in Cartesian. Now, there is a second definition of vectors, because if you notice, when I draw a vector like this, let me just kind of draw a qualitative sketch of this vector. It looks like this. And I can actually then measure the length of this arrow, which I'll write using the letter R. That's a weird thing to call a length. Just go with it. It relates to trig. So you're going to call it R. I know it doesn't make sense. Just deal with it. And it actually goes at an angle theta. Okay, so we can actually measure this angle theta, and then the way we write a vector that way is we say that the vector v is, you know what, I don't want to, I know it's a little thing, I'm going to print it just that I printed the other one. V is r at an angle theta. And so what I'll tell you is I have a vector 5 at an angle of, say, 45 degrees. And what you actually have to do is you have some kind of coordinate plane here, 1, 2, 3, 4, 5, and you actually get your protractor out and you measure 45 degrees, and you make sure that this vector has a length of 5. That's actually how you represent it. Now we're going to learn a simpler way of drawing polar vectors, and we're going to learn how to relate Cartesian vectors to polar vectors, but this is the polar definition, where you give the length and the angle theta. And when you define this in your notes, which I assume that you got your learning packet and you're looking at your notes right now, you want to try to sort of write this up in a more complete sentence. Right? So, there is one thing I'm just going to show you that we're going to be using in physics. I'm going to show you some basic vector arithmetic, and you're just going to do it. Okay, so let me just select everything here. And so for Cartesian vectors, suppose I have a vector 3, 4, and a second vector w equal to 4, 5. If I want to add v and w, it's really simple. I will add them like 3, 4 plus 4, 5. I will add up the x coordinates, so 3 plus 4 is 7, and then I add up the y coordinates, and that's 7, 9. That's actually the way to do it for Cartesian vectors. So this is like Cartesian vector addition. Okay, so this is pretty straightforward. I'm just forcing you to learn some math that we're going to be using in the physics class. Now, if I have polar vectors, say I've got one vector like v at 45 degrees and v2 at say 90 degrees. So, and actually, you know what, let me just get a different color on this. So, sorry about that. V at 45 degrees and w, say, at 90 degrees. And I want to add these. So let's just kind of represent them graphically. So I've got some vector, it's got a length v, and it goes at 45 degrees, and I got another vector 90 at 90 degrees. There's actually a way to do this. And the way this works is I would take this guy, okay, let me just copy it, and I would paste it here, okay. And boy, I don't know how they taught vector addition before the days of cut and paste. You paste it here, like that. So I take the head of this vector and bump it into the tail of the other, and then the resultant vector is it's like that. I connect the head of one vector to the tail of the other. And here's the crazy part. This and this are actually exactly the same thing. They don't look the same. They look totally unrelated to one another, but it turns out they're exactly the same. Okay. So again, I kind of showed you that trick there of how to add vectors. So the resultant vector, if I were to actually kind of put it here, let me just copy and paste it. The resultant vector actually goes in like that. There's actually another rule that they teach called the parallelogram rule, where you actually draw a parallelogram using the vectors. This is kind of trippy. You take this vector here and this vector here, and they form a parallelogram. It's very exciting. And then you can kind of connect the diagonals of the parallelogram. So you've got, again, I've got my two vectors here. If I wanted to add them, I could add them in the way that I call head to tail, where I take the tail of V, or the head of V, and bump it into the tail of W, and then I connect the head to tail like that. Or there's this parallelogram method where I draw a parallelogram using the vectors, and the sum ends up being this guy here. So both ways work, and we're actually going to use these when we deal with relative velocity, but you're not going to know that that's what you're doing. Okay, so let's kind of move on here. I want to actually talk about a couple things. So suppose I have my vector 3, 4. Okay. So, whoa, that's weird. Okay, let me just. So I've got my vector. My vector is 3, 4. And again, I draw 3 over 4 up on the coordinate plane. And I want to know the length. So I want to know how long the length is. Well, let's actually look at this vector more closely. I'm going over 3 units, and I go up 4 units, and this looks like a right angle. So it turns out, I'm going to show you some notation. The way you say length is this. You write the V like this in those two brackets, and to calculate that length, you use Pythagoras' theorem, 3 squared plus 4 squared. And so you're going to get a length of 5. So this vector actually has a length of 5. I'm using Pythagoras' theorem. If that was hard for you to follow, you need help in this class. You need to get a tutor. So I'm not saying you need to watch this only once and get it. I'm saying if you watch this 3 or 4 times and you're still puzzled, then you definitely need to get some outside help. So that is how to get the length of a vector. A couple of other math tricks. How to convert a vector from Cartesian form to polar form. So this is interesting. This is for those of you that have had a little bit of trig. And we're going to do just a small amount of this in class. So once again, I've got my vector. And we want to go from Cartesian form to polar form. So again, suppose I go over an amount x and up an amount y. Okay, I'm going to give you the formula. Basically, this thing here is the length of the vector. And if we wanted to get the angle that the vector points at, that's the angle theta here. For those of you that know trig, that would be the inverse tangent of 4 over 3. So the general formula is if I have a vector v equal to x and y, to get the length of the vector, that's x squared plus y squared using Pythagoras' theorem, and the angle is the inverse tangent of y over x. Now, for those of you that have had some trig, I want to challenge you to tell me if I have a vector pointing at r and an angle theta. You tell me, how do I get the x and the y? Okay. If you can do that, that would be very impressive, and that's what we're going to talk about a little bit in class next time. So this is a quick summary. We're going to talk a little bit in more detail in the I think I'm going to do like a second video where I go into a little bit more detail on how this works. So this is like a quick summary of formulas. And what I'll actually do is I'll just give you the formula r cosine theta and r sine theta to go from, so we've got two forms of vectors. We've got the xy form, where I give you coordinates, that's the Cartesian form, and then we have the polar form, which is r at an angle of theta. To go from this form to this form, I use x equals r cos theta and y equals r sine theta. To go from this form to the other form, we use r equals square root of x squared plus y squared, and theta equals the inverse tangent of y over x. So that kind of sums up what we're doing. Now, why this works is something that we're going to get into in a little bit more detail as we go into vectors a little bit more. I don't want to talk too much about it. We're just going to spend a little bit of basic time. So I'm making an assumption that you're totally fluent in Pythagoras' theorem and feel totally comfortable with this. So we'll get into that a little bit deeper. So I just wanted to kind of clarify this difference, or this conversion thing from Cartesian to polar. So to do that, I'm just going to kind of draw on this guy here. So here's a right triangle. It's got an angle theta here. Here's the 90-degree. And of course, we have a hypotenuse. I'm going to actually draw this triangle just a little bit differently. Instead of calling it A, B, and C, I'm going to call this capital R. I'm going to call this side Y, and I'm going to call this side X. So I'm going to use Pythagoras' theorem, and of course we know that R is going to be x squared plus y squared under square root. And for those of you that know trig, tangent of theta is going to be y over x. So if I wanted to calculate the angle theta, I would take the inverse tangent of y over x. And the other thing I wanted to say is that if I wanted to calculate the length of the side in terms of r and theta, I just wanted to point out a little trig here. For those of you that know trig, you know that sine theta from SOHCAHTOA is y over r. And so what that tells me is if I wanted to calculate the length of y, I would take r and times it by the sine of theta. Similarly, the cosine of theta is x over r. And so r times the cosine of theta equals x. So what I'm doing with vectors is I have a vector situation where I have a vector like this, and I can represent it using x and y, or I can represent it using the same vector. I can represent it using r and theta. And what I'm basically saying is I'm taking this vector and saying, well, here's the x part of the vector, here's the y part of the vector, and I'm using my basic trig and SOHCAHTOA stuff to relate one form of the vector to the other. So you do need to know how to go from this form to this form. And again, the formulas that get you there, to go from this form, to go from Cartesian to polar, r equals x squared plus y squared, and theta equals the inverse tangent of y over x. To get the x and y form, you're going to actually use your trig r cos theta and r sine theta to convert. So you've got to know how to use both formulas, and you're going to actually do that in class next time.